Hello dear students, welcome back to Learn Physics. In today's video, we are going to discuss about the chapter Laws of Motion. So here in today's topic, we are going to discuss about some pattern problems, that is about the first type of questions which we are discussing is about the resolution of forces. Resolution of forces. How we will be resolving this force vector. Okay, so here we can, in this situation, this type of forces, how we can resolve. Here we have two types of resolutions there. If the object is at equilibrium, then we know the net force acting on the system is equal to 0. Then, if net force is equal to 0, what is the meaning of that? Net acceleration acting on it will be also equal to 0. If acceleration is equal to 0, what can we say? That is, the object is moving with a constant velocity. Right? So this is the first type which we will be using. That is, if the system is at equilibrium. Okay, if the body is at equilibrium, net force acting on it is 0. That means the total acceleration acting on it will be equal to 0. If acceleration is equal to 0, velocity is not changing, so velocity is a constant. Now, we are going to consider the second set of resolution of vector. Then accelerated motion. Or we can say, if it is at temporarily at rest. Temporary rest. If the object is temporarily at rest, it was under acceleration and temporarily coming to rest position and then coming back. So we will be discussing about such kind of questions now. Now, first I am going to consider about the first situation. There, force is equal to 0. So, since the force is equal to 0 there, we can consider, or we can resolve the vector in any direction. We can resolve the force in any direction. Okay, we can resolve the force in any direction. So, here we can consider as net force is equal to 0. So, in all the directions, any direction we can consider, because all the directions force is equal to 0. But in the second situation, while we are resolving the forces, along the force, we will be considering the force which is along the direction of acceleration. Usually, we will be considering the force along one vector will be along the direction of its acceleration and the other one will be perpendicular to that. Okay, and here the net forces along the direction of acceleration will be equal to ma. So here we considered about the two situations where the forces acting in the direction of we will be considering the force, one of the forces in the direction of acceleration. And another one component will be perpendicular to that. So when we are considering since the force is acting in the direction, one of the component is acting in the direction of force and the other is perpendicular to that. What will be the force acting on it? That force acting on it will be equal to 0 because the object is moving in this direction only. So the force acting on it will be equal to 0. That is for accelerated motion. Here in the second situation, we considered it as the object is accelerated and temporarily at rest. So here, if the object is accelerating, the conditions only we told now. Here as if it is accelerating, the object, we will be resolving it into two components. One is acting along the direction of the motion and other one is perpendicular to that. If it is accelerating in the direction, so the force is acting, F is equal to ma. Perpendicular to component, force will be equal to 0. Next is, if the object is temporarily at rest. If the object is temporarily at rest, how can we consider that? See, I'll tell you three situations for that. So first one, I am throwing an object with a particular velocity u. When it is reaching to the maximum height, what will be its velocity? Velocity will become equal to 0. But at that time, acceleration is g. That means it is not equal to 0. Right? So acceleration is acting downward direction. It is not equal to 0. That is, here the object is temporarily at rest here. Then another situation through the inclined plane while the object is moving in the upward direction with a velocity u. And when it is coming to the maximum position, what will happen? Maximum height when it is reaching, final velocity will become equal to 0. But here acceleration is not equal to 0. It will be moving downward direction. Right? So here in this, this is also a temporarily at rest. If the object is temporarily at rest, the velocity of the body will become equal to 0 and acceleration is not equal to 0. Okay, so the direction of acceleration in this case is in the direction in which the body is supposed to move just after a few seconds. So that means when velocity is equal to 0, afterwards the acceleration is acting in the direction where after few seconds in which direction the object will be moving. And now another situation I am considering here. See, simple pendulum. See, a pendulum, a bob is a thread and a bob is here when it is under motion. When it is coming to this position, it is initial velocity u is there, final velocity will become equal to 0 and acceleration will be acting just opposite to the direction. Right? This will be the acceleration. Acceleration here it is not equal to 0. Clear, children? So these are the different situations. Now we are going to consider in such kind of situation. I'll tell you one example also for such kind of situation. Okay, here same like simple pendulum only I am considering. Here fixed position. This is from here a thread and a bob is attached to it. That is P, which is connected to a fixed end R. Okay, now with respect to the vertical, it is making an angle theta, and when it is reaching to the other end, after this motion, it is coming to this end. Okay, this one I am representing it as Q. Now, here body mass of the ball is given as 1 kilogram. Mass of the ball is 1 kilogram, which is at rest in P. Okay, here it is attached with it. Since it is attached here, it is not moving to the other end. Now, it is attached with the fixed end P. Okay, so this OP is one of the strings and RP is another string. Okay, OP is a string and RP is string. Now, if the string RP is cut, what will happen? This ball will be swinging and coming to the position Q. If this theta is equal to 45 degree, find the tension. We need to find out the tension in the string in position OP when RP was not cut. If we need to find out tension at OP if RP is not cut. And we need to find out the tension at OQ at this position when RP was cut. So these two situations, how can we find out the tension? This one we are going to find out. Okay. So this is the situation. Let the question be here only. Now, for that, usually what we will do while getting a question, we will draw the free body diagram. Right? So here, this is the position of P. P is, it is not cut. So P is attached with the R here. Okay. It is attached to the fixed end O. Now, a tension will be acting in this direction. Mg will be acting downward direction. So you will think a tension will be acting in the opposite direction also. Here, how I can divide this force? This force, my aim is to find out the tension which is acting along OP. mg is acting downward direction. So I can divide this OP into two vectors. How can I divide? It is one vector is here and another vector is here. If this angle is theta, what will be this angle? This angle also will be theta. Then here we will be getting it as t sine theta. And the other one which I am getting over here is, this is t cos theta. Okay, so I am getting a t cos theta in this direction. Right? So that t cos theta is balancing with mg since it is not cut. It's at rest. So t cos theta is balancing with mg. I can find out t as mg divided by cos theta. M value it is given as 1 kilogram. 1 into 9.8 or 10 you can write it. Cos 30. Cos theta is 45 degree. It is given, right? Cos 45 1 by root 2. So 9.8 root 2 or 10 root 2 Newton. This will be the tension acting on it. Okay. So next we need to find out the tension acting on OQ if RP was cut. What is the tension acting on OQ? For that first we will draw the diagram. See here for drawing the diagram. I'll draw the diagram over here. If it is cut. So now this is cut and it is moving to this point. Now P is at this position Q. Okay, the ball is at the position Q. So what will be the forces acting on it? Still mg is, see this is OQ. mg will be acting exactly downward direction. And tension will be acting in this direction. TOQ is acting in this direction. Through the string, it is in the opposite direction. Now I can consider this as theta. Okay, so here when I am considering this as theta, how will we divide that into components? I can divide G into component mg as, so this is the tension which is acting. This is equal to theta. If this is theta, this also will be equal to theta. That one I can divide it into G cos theta and this is G sin theta. So what will be the force which is opposing TOQ, tension at OQ? It is dividing it into, see here, TOQ. How can I write down TOQ equals mg cos theta, right? Now I can find it out. Tension at OQ equals m is equal to 1 kilogram, 9.8 cos 45 is 1 by root 2. Okay, so here I'll be getting the value as 9.8 divided by or 10 by root 2. Or I can write it as 9.8 or 10, nearly equal to 10 root 2 by 2. So 5 root 2. I'll be getting it as 5 root 2 Newton. Okay, now what did you understand from this? This tension at OQ, when it is coming to the other end, and when the tension is acting on the string, if it is not cut, and after cut, both the positions we are getting the different values for tension for the same string. Okay, for the same string, here we got the value of tension as 9.8 root 2 we got, right? That is nearly equal to 10 root 2. But for this case, we got it as 5 root 2. That is here 10 root 2 and this case 5 root 2. So this is how we will be solving the situations where resolving the vectors or resolving the force into its components. One will be acting in which direction it will be. Tension is acting. Through that direction, we will be finding out the components. Clear, children? So this patterned question is clear for you, I guess. In tomorrow's class, I will be coming with another example, another type of question, that is how to find out the tension at some point if it is variable. Okay, if we are considering a variable, how to find out the tension. That one we will be discussing in tomorrow's class. So I hope today's class is useful for you. And if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.